the topic is set and set operations, and under that we are going to have a look at two set problems and De Morgan's law, right? De Morgan's is one of the mathematicians that has proved some identities, right? So in no time we have a look at that very soon. So under this we will talk about two set problems and De Morgan's law or identities, right? De Morgan's law or identities. Okay, so the first part of this is two set problems. So let's do a quick revision over here, right? So maybe the book I'll be using here is Aki Ola publication. So credit to Aki Ola for supporting us today. So let's have a look at the first example. The first example that we are going to talk about is here is it. So in a class of 40 students, 30 read mathematics and 20 read English. Each student reads at least one subject. How many students read both mathematics and English? So of course this is a two set problem because it involves only what, two subjects in that. So my advice to you is that don't read as if you are reading just a graphic or a newspaper. Is that okay? So when you read the first part, all that you have to do is read a sentence by sentence and write what it means down. So without wasting time, let's dive into it. The first part or the first sentence is that in a class of 40 students. Okay, maybe before you start that, let me give you a quick review on how to represent everything on the Venn diagram. So this is how the Venn diagrams looks like. Okay, this is how the Venn diagrams looks like. So here this is where we are having our U. Our U represent the universal. So what I do is that I use some assumption to for better understanding, right? So the understanding is that the universal set or the rectangular shape here is that I consider that one to be a house, right? When I have a house, there are some people inside, there are another rooms inside the house. So let's consider this one to be the house, and within the house I'm having two different rooms, right? I'm having two different rooms over here. So this is the entire house over here, and then I'm having two different. The reason why I overlap is that let's consider in the case where some people sleep in room 1 and then the next day they'll go and sleep in room 2. Is that okay? Maybe today you may sleep here and then tomorrow you go and sleep in the second room. Maybe that is the notorious in some case. That's the reason why we overlap this. So for you to be able to overcome these set problems, you should know where everybody belongs to, right? You should know where everybody belongs to. So which people are supposed to be here, which people are supposed to be here, and then which people are also supposed to be here. And that is one thing you have to have at the back of your mind. So the moment you start reading, you know where everybody belongs to on the Venn diagram. The Venn diagram is nothing but just a pictorial form of what? A representation. And that is where you represent information so that everything can be clear. Is that okay? All right. So now we have that in a class of 40 students, right? Now the question is, where is the 40 belongs to, or where is that 40 supposed to be on the Venn diagram? So they say in the class, right? So the whole class here we are having what, 40. So that will be the universal. Everybody, those who in the house. So, okay. And then the second sentence says that 30 read mathematics. So that should be the first part, right? So let's represent that 30 by M. Capital M, right? So capital M, the initials of the subject. Is that okay? So 40 read what? Sorry, 30 read mathematics. So 30 over here. And then let's move on. So we are having another one followed by what? 20 read English. So English, the initials of your English is E, which is what? 20 over here. So 40, 30, and then 20. So once you see where everybody belongs to on the Venn diagram, I think this will be okay. Try and understand this. So when you get to the 3-set problem, things will be very easy for you. Okay, then let's move on. They say each student read at least one subject. What it means is that there's nobody outside the rooms. Is that okay? Those are the 2 rooms over here. They say each student read at least one subject. It means that no one is outside, it's on a compound, right? No one is on the compound. Everybody belongs to a certain place, right? So pay attention to that. Now they say how many students read both mathematics and what English. Okay, so these are the only information that we have available now. Now for you to be able to answer these questions, you have to make sure that you fill in the rest of the spaces, right? So 1, 2, 3. So the spaces, we make sure that you fill in everything over here. Once again, you have to know that this portion here belongs to those who are doing what? The 2 subjects, right? Those notorious people, or maybe let's say the sharks. So those who are doing the 2 things are here. And which people are supposed to be here and which people are supposed to be here. So this portion here, as you can see, this portion here belongs to those who are doing mathematics only. Just this small portion over here. This portion here belongs to those who are doing the mathematics only. And here also belongs to those who are doing what? English only. Right? They don't do anything apart from the English. Here too, they don't do anything apart from what? The mathematics. And then here are those who are doing the 2 things. Is that okay? Those who are doing the 2 things. So I know that everybody here, those who are doing the mathematics are 30. If they are 30, then which people belongs to this portion only? That is the point, right? So when I say that, let's have a quick one over here. When I say that five students are doing mathematics, so let's say 5 people are doing mathematics over here. 5 people are doing mathematics. Then, and I say out of this, 2 people do what? Math and science. Is that okay? Math and science. So math and science. 2 people do math and science. When I'm counting mathematics, do you know that I will count these people in addition? Is that okay? I have to count these people in addition, right? So 5 people are doing mathematics over here, and then 2 people are doing math and science. So can't you see that these 2 people are part of the mathematics students? So when you call on mathematics students should come up, and these people also have to get up. Is that okay? Making them 5. But when I say those who are doing mathematics only, then it means that these people have to be out. Are you getting the point? So these people are doing math and science. So I need the mathematics only. Is that okay? So therefore we need, that should be 2, 5 minus 2, which is equal to 3. So only 3 people are doing what? Mathematics. But those who are doing math and science are 2. But when they say the mathematics students, then these people and the mathematics only people has to get up. Okay, so now let's get back to our questions over here. So that is why we know that the whole people who are doing mathematics here are what? 30. Is that okay? And then here, what to be at this portion? Currently we don't know. We don't know those who are supposed to be here, right? We don't know those who are supposed to be in what? The intersection over here. It means that those who are doing the 2 subjects, right? So let's name that A, right? A, small a. Since these people are doing the 2 things, you have to take them out of the mathematics set in order for you to know those who are doing only what? The mathematics. So I have minus A over here, and then here will also be what? 20, and then minus A, right? 20 minus A over here, right? Okay, but what do you know? We know that the whole compound, right? In the whole class we have what? 40 people over here. So everybody here has to be equal to what? 40. I know where we are going. We want to know those who are doing what? Both mathematics and English, right? Those who are doing both mathematics and English. So therefore we need to find out or figure out those who are doing that. But without wasting time, let's add everything together. So that will be 30 minus A plus, let me use a new marker here. So 30 minus what? A plus A plus what? Another 20, and then minus A. Can you see that? Can you see that? So 30 minus a plus what? 20 minus. So I'm just adding up, right? I'm adding up everything over here. So that will be 30 minus a plus what? 20 minus a. All has to be equal to what? 40, right? All has to be equal to 40. Then you do your calculation over here. So here, this guy and this guy will go away. Can you see that? This guy and this guy, because minus and negative positive. If you want to break it down, you can say that you are just having something like a 1, right? And then you are owing someone 1, then you are having 1. If the person takes it, then you don't have anything. It's okay. Or maybe 1 step forward and then 1 step backwards. So you are still at where you are, right? Okay, so that's the reason why this guy and this guy cancel out. So I'm having 30 and then plus what? Like 20, then minus what? Minus a, all will be equal to 40. Is that okay? So then when you do this calculation correctly, so that should be 50 minus a should be equal to 40, and then maybe you can send this one and then send that one out, whatever you want to do. So that one there, so that should be 50 minus 40 is equal to a. This guy is going away, so I'm having 10 is equal to a. Yeah, it's the same as this implies that a is equal to 10. So when I turn it other way around, so therefore we are not looking for a. That is one thing you have to know. The question is say that this a, where do they belong to on the Venn diagram? They belong to what? The middle, right? And also are doing the two things. So therefore I say therefore those who read, or maybe student, those who read, let's say English and what? Mathematics are what? 10 students. Is that okay? So those who read English and mathematics are 10 students. Very simple. You have to answer the question because nobody knows a. So okay, nobody knows a over here. So that's just a quick one on about the two-set problem, right? There's nothing more for you to understand it here. So all that you have to know is that know where everybody belongs to on the Venn diagram. So when you read a sentence by sentence, you should know where to place them. All right. Now let's move on to the Morgan's law. So this is just an identity, right? When I say an identity, they are just some rules which has already been proved to be what? True, right? Which have already been proved to be what? To be true. So all that you need that you should know how to use them. Okay, all that you need is to know how to use them. Now for the two-set problem, we will prove for the two-set problem, right? You prove for what? The two-set problem. Then you also quickly